Alright, this is part 3 of the joint analysis inside LS-Dyna, basically how to set up different kind of joints. For a spherical joints, it's extremely simple. All we have to do is create a couple points that's going to be located coincidentally in the center of both spheres. And then what we do with that is we're going to use the coordinate joint COR card to basically write out the joint. You're gonna need two CNRBs, which ties to the two spheres, and then the CNRB number is gonna be used with this card here to generate the joint. These two set of coordinates are coincident, essentially creating, turn the music down a little bit. Essentially creating the joint conditions for the spherical joint, and what you get are something that look like this. All right, pretty simple. You can sort of see even with distinct bending, this joint is maintained. And this is how you can use a joint like this in the larger model. Okay, so let's do a quick demonstrations, right? We're gonna call this the ball 1, and we'll call this ball 2. What we're doing here is we're going to create a coordinate that we're not gonna use, except in this case, we're gonna generate a coordinate system here that's going to be at the center of the spheres right here. And then I'm gonna hide this, and then I'm gonna generate another coordinate at the center of the same sphere. And you can sort of see these two are, well, theoretically they should be in the same geometric locations. And if they're not, we just need to make sure we adjust it so that they aren't. Alright, so you can sort of see these two coordinates are slightly different. But what we want to do is to make sure they're actually in the same locations, right? So what we're gonna do is we're gonna generate. Well, let's go ahead and mesh this first. Sure, let's just use the default mesh. It doesn't really matter what mesh we use. And what we wanted to do is to make sure we select the surfaces here. I want to call this ball 1. Hide it. I want to call this ball 2. And then the ball 1 and ball 2 are essentially these surfaces, which I'm going to turn into nodes. Node selection region, node selection region. I'm going to call this ball 1 nodes. CNRB. And I'm going to call this ball 2 CNRB. Okay, and for the ball 1 CNRB, I'm going to give it a value 9001, and then I'm going to give this to 9002. The reason I'm having these into two different nodal selection sets is because I want to be able to create a custom keyword right here. And what I'm going to do right here is I'm going to call this the constraint joint COR sphere. And then what I'm going to do with this is that I'm going to first create the constraint nodal rigid body. I'm going to tie it to the nodes 9001 and 9002, which are, this is my CNRB number 1, this is my CNRB number 2, right? And what I'm going to create a CNRB called 8001 and 8002. These two are going to tie to those nodes that's in those two node sets. And that's going to be my two CNRBs. And then what I'm going to do next is I'm going to tie those two CNRB together so that they can be tied together through a joint. And the joint I'm going to use are based on this coordinate right here, right? And this coordinate I believe is going to be based on this one, right? So for example, if I just do oh, I'm sorry, let me change my units a little bit so that it's easier to see. Right. So if you look at this nodal location are going to be the coordinates that I'm using for the rotational center point, right? And then you can sort of see these two set of nodal coordinates have exactly the same value, which means they're coincident. And now this one is actually slightly off from the previous one, but that's okay. I'm just gonna make sure this one is gonna be rotating relative to this one in a spherical manner, and I'm gonna tie both nodes to that CNRB in the same locations, basically. So which I'm gonna use this one to do, and this is basically generates my joint, right? And then if you want to set up something else, we can just set up a quick conditions, right? So for example, I can add a fixed support to this side right here. that's gonna fix one end of the joint, and on the other end of the joint, I can add a remote displacement. Which, for example, I can add a remote displacement to this, and that's gonna generate remote displacement relative to, say, for example, this coordinate system. I'm gonna call this the joint coordinate, right? And then I'm going to tie this remote displacement to the joint coordinate I just created, and then I'm gonna say this thing can rotate by, you know, say 45, 45, and 45 degrees. Make that rigid. And then you can also say translate downward in the y-axis by say 5 millimeters. The number itself is basically made up, and I want to make sure I tie that no remote point to that location right there. And this is basically what's going to allow us to generate uh, the spherical joint relationship that you see here, right there. Okay. And lastly, usually for problem like these, you can turn off the control cards and turn off the database cards if you want it. That usually helps. Then you can just write on your own database cards. In this case, there really isn't anything that's needed. So all I'm gonna do is I'm gonna do a join force, and I'm gonna do a database plot, and that's just gonna generate some D3 plot states for the final model. Okay, and this is a quick demonstration of how to do this. And this right here is how you generate a joint analysis like this for a spherical joint.